it says to list, listening please, it says to list the first 5 perfect cubes, and then it says something about the 4th power and the 5th power. I'm just going to list the cubes, because truly I don't even know the 4th and the 5th and the 6th off the top of my head if we're thinking about different values. They get really large really quick. But cubes are something that I think is important to kind of be familiar with and know. So let's start with 1 cubed. 1 cubed, remember, is the same as 1 times 1 times 1, which is 1. 2 cubed would be the same as 2 times 2 times 2, which is 8. And I won't write it out that way every single time. 3 cubed, do we know that one? 3 times 3 is 9, times another 3 is 27. 4 cubed. Anybody know that one? So 4 times 4 is 16, times another 4 is 64. 5 cubed. So 5 times 5 is 25. If you have 5 25s, 125. Yeah. So those are the first couple. Again, it's just kind of nice to know them. It's kind of like knowing your multiplication facts and other math facts. It's just, if you know them, it just makes life a little bit faster and easier to do some of these problems. A friendly reminder that when you're finding roots, if you have an odd index number, first of all, do you know what index number means? If I say index number? Okay. If I have this, what type of root is that? A square root. How do you know? There's no 2. We just know, right? Okay, so this would be, my index number would be 2. If I had a cubed root, then my index number would be 3. If I had a 4th root, my index number would be 4. So again, I think you guys know by now that I'm not going to ever give you like a vocabulary quiz. That's not something that's ever going to be in your future. However, if I say the word index number, you kind of want to know what it is so it makes sense to you. So index number is this little guy. Then radicand. Radicand is the thing under the root. So when you see the word radicand, that's another good word to know. Radicand is what is under the root. Okay, so those are 2 kind of nice vocab words to know. Again, not because I'm ever going to quiz you on vocab, but because if I use them in a sentence, you'll know what I'm saying to you. Or if you see them in the directions of a question, you'll know what it's asking. So if you have an odd index number, remember you can take the root of something positive or negative. So if you have an odd index number, cubed root, 5th root, 7th root, you can take the root of that thing, whether it's positive or negative, and get an answer. And you're going to get one solution. However, if you have an index number that's even, you're taking a square root, a 4th root, a 6th root, an 8th root. It depends on what's under it. If what's under it is positive, you get 2 solutions. If what's under it is negative, then you're going to get no solutions. So it depends on whether or not we have a positive or a negative. If we are taking the root of 0, it's always going to give us 0. All right, so let's come down here and let's find the 6th root of 64. So this is worth finding on your calculator. Also, what is throwing me off today, and the reason I'm listening to spa music, is because I left my bag at home, like my school bag, and so Pinky's not here, you guys. So we're going to have to bring in the backups. All right, if you have a calculator like this, I'm going to help you first. If you have a scientific, I'm going to help you second. So, if you have a calculator like this, I want you to press the number 6 because you want to find a 6th root. Then I would like you to press your math key, and I would like you to go down to option 5. Do you see how 5 has a little baby x where the index number would go? Okay. If you hit enter, it's going to take that 6 that you just typed in and it's going to put it there. So you always want to type the root first, then hit math, and then go to, what option was that? Option 5. And then, oh, nope, I want to be under here. And then underneath, you'll type in 64, and it's going to give you your answer. Now, truly, if we were solving, we would say plus minus 2. If you're simplifying, you would just say 2. So you need to be careful whether or not you're solving. So if this question was a solve question, this would be my answer. I would say, yep, it's going to be plus minus 2. And that's what we're doing right now. We're solving. We're finding the real roots. If it had just been a simplify question, my answer would just be positive 2. So solving, you get the plus minus. Simplifying, you just get the one value. We don't account for all the things. All right, let's say you have one of these calculators. It's very similar. I want a 6th root, so I'm going to type the number 6. And then the root key you need is above the caret key. So if you have this one, you're going to hit 6, and then you're going to hit 2nd caret key. 2nd caret key. And then you're going to type in 64. And it gives you the same thing. Okay. Cubed root of negative 216. So I'm going to do the cubed root the same way I did the 6th root. So I'm going to type in 3. I'm going to press math. And I'm going to go to option 5. And I'm going to type in negative 216. And I get negative 6. Again, if it is a cube root, you're only going to get one solution. There's no plus minus. So whether it was asking me to simplify or solve, it would be the same answer for this one. Again, if I'm on this calculator, I'm going to clear it. I would type in 3, 2nd caret, negative 216. And I would get negative 6. Okay, next one, try typing it in without me and tell me what you get. Oh, yeah, this one isn't even going to come out nice, is it?
It just is error.
It is an error. Look at your chart. Can we take the 4th root? 4 is an even number. Can we take the 4th root of something negative?
0 real roots.
Yeah, so there is no real solution. Is there a solution? Yup. Is it imaginary? Yep. So for our purposes, though, we're just going to say no real solution for right now. So I will let you know when we need to go into imaginary land and start giving those answers with eyes, not for this. Okay, so this is not a section where we go into the imaginaries. All right, Flip, when you're ready, we're going to do some more examples. These are usually, let's see how many I've got. Yeah. These are usually pretty tricky for people. Okay? I'm not even going to start with the properties. I'm going to go down here. All right. So again, the reason they've got signs out front is to just kind of throw some extra options into you for what can happen. So I'm going to carry the signs down. Let's start with 81. So take it piece by piece. Okay, that's what I'm doing with today. I told you, I'm having a very Monday-ish Monday. Today is not my day. So I am taking things baby step by baby step because we can do this, but one step at a time. So start with just the 81. What's the square root of just the 81? 9. What is the square root of x squared? X. Good. What about the square root of y to the 8th? Do you know what to do with that? So let's write ourselves a little note up here. Let's say we were taking the square root of y to the 8th. That is the same as me taking the 8th power and dividing it by 2. Do you agree my index number is 2? Okay. And what do we know 8 divided by 2 is? 4. So this is going to be y to the 4th. So for these problems, you are going to divide the exponent by the index. So this will be z to the 2nd. So again, divide, and that's a note you can write over here too if you want. Divide the exponent by the index number. And notice that the first problem we did, and even the second problem we're going to do, is going to turn out all nice and rainbows and perfect because everything's nicely divisible and nicely square rooted. We're going to start to get into situations where that's not the case, and those are the ones where people have a little bit trickier of a time. Okay, so we have a negative, but it's out front, so it's okay. So it just carries on down. What do we know the square root of 49 is? 7. Okay, we've got x to the 20th. Remember, we're dividing by our index number. So 20 divided by 2, 10. And y to the what? 6, because 12 divided by 2 is 6. So the nice thing about these is that they're usually one step or 2 steps at the most. They're pretty quick. It's remembering the rules that's the trick here. And for me, it's seeing the little baby index numbers. That's also the trick because those are tiny. Okay, cubed root is next. We just talked about this one. Do you remember? What's the cubed root of 27? 3. Nice. Okay. X to the 9th. Remember, we divide. So 9 divided by 3. Y to the 18 divided by 3. 6. And again, you might want to write yourself this note off to the side if you haven't already, because when you look back at this later and you're like, where did I get y to the 6? Help yourself out. Help yourself remember where it came from. Ooh, I don't know this one. I want to say it's 4. It is? Okay, good. So the 4th root of 256 is 4. Again, you can do that on your calculator if you need to. Ooh, this is the first one that's tricky. Do you see my problem? Okay, we're going to deal with the z separately in just a minute. Let's start with the x. 4 divided by 4? 1. 12 divided by 4? 3. Okay. That z is a little bit of a problem child. Is 5 nicely divisible by 4? No. It's not awful, but it's not nice, right? Okay, so then here's the game I play. I drop down as 5. So I think about 4. Is 4, the next one down, is 4 nicely divisible by 4? Okay, so I'm going to break z into 2 pieces. I'm going to break z into z to the 4th times z to the 1st. Do we agree z to the 4th times z to the 1st would be z to the 5th because we add exponents? Are we okay with this being the same as this? Okay. Now, can I take the 4th root of z to the 4th? Yes. What is it? 1, right? It's z to the 1st. So I've got 4x y cubed z, and then I still have my 4th root of z to the 1st. Can I take the 4th root of z to the 1st and have it be nice? No. So it lives on under the root. So you're going to have kind of a combination of things at some point, because not everything is a perfect root. Not everything is a perfect cube. Not everything is a perfect 4th root. And so when we encounter something that isn't, we have to kind of break it apart into things that we can take the 4th root of and things we can't. Anything you can't take the 4th root of lives underneath. Remember, as soon as you've applied the root, it pops out front. Okay? Let's do some more of these. So flip the page when you're ready. There are more examples. It's the same idea, so it's not, I'm not changing into anything new. It's more of the same. Okay. All right. So part E has more stuff that isn't perfect squares. Is 50 a perfect square? No. So we're going to break things into things that are perfect squares and things that aren't. So let's start with the 50. Think about things that are perfect squares. What perfect square can divide evenly into 50? 25. So I'm going to break the 50 apart into 25 times 2. So this piece is a perfect square, this piece not so much. Let's go to x to the 4th. Is 4 nicely divisible by 2? Good news. We'll just leave it as it is. It's all good to go. Is 7 nicely divisible by 2? No. Drop down a notch. Go to 6. Huh? I'm looking at the 7. So I said, is 7 nicely divisible by 2? The answer is no. So we drop down 1. Go to 6. Is 6 nicely divisible by 2? Okay. So let's break it into y to the 6th times y to the 1st. So y to the 6th is going to be the part that's nicely divisible. Y to the 1st isn't. Okay, now, yeah. Huh? I'm going to in just a minute. I haven't done anything with the root yet. I'm just breaking stuff apart so that when I go to square root, I'm ready to rock. Okay, now, do we agree the 2 isn't square rootable? It's going to live on underneath. What else isn't nicely square rootable? Y to the 1. I'm pretty sure I made up that word. I doubt square rootable is in the dictionary. I think it should be too. So those two things should live on underneath. If it's not highlighted in pink, it should end up out front because those are all perfect squares. What's the square root of 25? What's the square root of x to the 4th? X squared, because we do the 4 divided by 2. What's the square root of y to the 6th? Y cubed. Then I have my square root, and my 2 and my y to the 1st need to keep living under there because I can't square root them. And I'm going to box this in. This is my final answer. So again, as soon as you apply the root, it pops out front. All right, let's look at the next one. We've got to do the same thing. We've got stuff that's perfect square root and stuff that isn't. All right, here we go. Breaking things apart. Is 32 a perfect square root? Yes, no? No. What divides in that is a perfect square root? 16. And I know 16 times 2 would get me back to 32. What about x to the 6th? Is 6 nicely divisible by the index number of 2? Yes. So I'm not even going to mess with that one. That one's good to go. What about 5? Is 5 nicely divisible by the root of 2? Bummer. Okay, let's drop down a notch. What about y to the 4th? Yes. Okay. So y to the 4th times y to the 1st. Okay. The things that are going to stay under are 2 and y1 because, again, they're not nicely square rootable. All right. If I take the square root of 16, what is it? 4. What's the square root of x to the 6th? What's the square root of y to the 4th? And then these were my two pieces that I knew I couldn't take the square root of, and they stay underneath. So far, so good? Okay, these are, like I said, if people struggle, this is typically the spot where we have struggles. All right, let's go to the next one. Is 16 a perfect cube? Bummer. So we're going to treat this the same way we would have had it been a square root. We're going to break it into pieces. What goes into 16 that is a perfect cube? 4 is not a perfect cube. 8. So we're going to go 8 times 2. Okay, now look at this. Is 6 nicely divisible by 3?
Yeah.
Good news. Is 10 nicely divisible by 3? Bummer. Go down a notch. Is 9 nicely divisible by 3? Okay, so I'm going to break this down to y to the 9th times y to the 1st. By the way, what's left under the square root isn't always 2y. I feel like that's what's happening for all these problems, but it's not always 2y. That's just,
For the next one, it's not. So.
for the next one, it's not good news. Okay, so not square rootable, not square rootable. Again, my new word that I made up. All right, what do we know the cubed root of 8 is? 2. X to the 6th divided by 3. X squared. Y to the 3rd. And then I have my cube root. And then I have 2y. Now, I am an awkward person in general. I think it's just who I am. I've accepted it at this point in my life. And speaking of awkward, I put an awkward break in between anything that's out front of a root and my root. Do you see if I had put them super close together, it might have looked like y to the 33rd power, or it might have looked like the 33rd root. So just as I am an awkward person, I leave awkward spacing. And so my awkward spacing is right here. I leave way too much room because then I don't think it's y to the 33rd or the 33rd root. Okay, so I would recommend that you do the same so I can tell what your roots are. Okay, next one, ready? I'm going to actually add, I realize I need to add one additional problem, I think. Hold on. Yeah, I want to add one more thing. Because we didn't have a fraction one, so I'm going to add a part I in a minute. Just so you know. No, we got to do part H. Here we go. Cubed root. Ooh, I don't even know what goes in there. That's a perfect cube root. Does 125? Probably. 4,000 divided by 125. Ooh, it goes in there 32 times. I think there's something bigger. Let's see. 2 to the 3rd is 8. So 125 times 2 is 250. Hold on. Let me do the math. I don't even know the answer to this one yet. 8 times 125. Oh, so 1,000. I don't know why that took me so long to figure out. 1,000 times 4. So 1,000 is another perfect cube because 10 times 10 times 10 is 1,000. So 1,000 times 4 is how I break it apart. Is the x to the 9th nicely divisible? Good news. Y to the 5th, is that nicely divisible? Okay, drop down. Y to the 4th. Drop down. Y to the 3rd. Yes. Okay, so y to the 3rd is what I need. So what do I need to multiply that by to get back to where I started from? I'm going to have to move I somewhere else, by the way. We'll still do a part I, but it's going to have to go elsewhere. So y to the what? Y squared. So if I multiply these two back together, they'd add back up to 5. This is my part that's nicely divisible. This is my part that isn't. Is 15 nicely divisible by 3? Yes. So that can stay put. All right, so the things that are going to live on under the root. The 4 and what else? Y squared. So we changed a little, but not much. All right. Cubed root of 1,000 is? 10. Okay. Cubed root of x to the 9th. Cubed root of y to the 3rd. Just a y. Cubed root of z to the 15th. Z to the 5th. Under my cubed root, again, awkward space. Under is this. Good? Okay. Awkward pause. Put it right there. Okay, we're going to do a part I. Do for me a big square root because it's going to be like a double-decker bus under here. Let's go 4x to the 4th over y to the 8th. So the stuff under it is nice. Do you know how to square, oh, sorry, let me move that up. I see people straining to look. Do you know how to square root something if it's a fraction? So basically, you can think of it as two separate parts. You can think of it as square rooting the top over square rooting the bottom. What do we know the square root of 4 is? What's the square root of 4? I don't know where I want to write this. 2. What's the square root of x to the 4th? X squared all over y4. And this would be my final answer. So if you ever come across a fraction that needs to be square rooted, that's fine. We can do that. We just need to square root the top and the bottom separately from each other. And let me make sure there are none that need to be rationalized in your homework. Otherwise, I need to talk about that too. Hold 1 second. See if that's a today topic or another day topic. That is not a today topic. Okay. Lovely. That's where we stop for today. How are we doing? Okay? I think the highlighting helps. I've never done it that way before where I've highlighted the stuff that stayed under the square root, and I think that might help. Let's see what you guys think. Okay.